Joining us now is Sam Crickman, an assistant professor at Northwestern University's McCormick School of Engineering and the lead researcher of his AI team at NU. Good morning, Professor Crickman. Thank you so much for joining us.
Thanks for having me.
When I first covered your discovery of an AI-designed robot, it amazingly surpassed 100,000 views on YouTube within 1 week. People are so excited about it and wanted to learn more. That's why we're having an exclusive interview today. Congratulations.
Thank you.
And for those who haven't been following this topic, would you please explain what your discovery is and why it is so important?
So we figured out a way to have an AI system help us design a robot. The robot is very, very simple, but it represents a first step in a new kind of machine that AI can help us design.
It seems that you mentioned the word evolution quite frequently. How is that related to this research?
The only way that we knew how to design robots in the past was either using human intelligence or using an evolutionary process inside of a computer. So just like evolution resulted in all of the animals and plants and amazing organisms we see on Earth, we can also run that kind of process inside of a computer, but it relies on chance, random mutations. This takes a very, very, very long time. It took billions of years on Earth to result in animals, and it takes weeks of supercomputing to result in robots inside of a computer. So we figured out a way to do this much, much faster. In a way, we taught evolution how to make very smart changes to the design of a robot.
It's 26 seconds, right?
So it took 26 seconds to create a very simple walking robot, but there's no reason that this process couldn't be optimized to run in milliseconds on a cell phone. So it's a very efficient process. Now, it remains to determine how this will scale to more complex machines. So this robot just has muscles and a body. It doesn't have a brain, it doesn't have eyes, it can't perform any useful work yet. So we hope, though, that because we made this process of evolving a very simple robot go from weeks to seconds, that the process of evolving a useful, more complex machine might go from millennia to a year.
We actually have a related question from our audience, quoting, "Nature took billions of years to evolve, and yet some species are naturally adept at swimming, while others are born to fly. Why don't those who can fly swim? Why don't those who can swim walk? And why can't those who walk fly? What does walking even mean? Does walking on 4 legs not qualify as walking? Is walking on 3 legs not considered walking? Or is it only when walking on 2 legs that is considered walking? Tag USTV, please explain." All right, user AREQTW5A491, we hear you.
There's many, many ways that animals move across the world. Some of them swing from branch to branch. Some of them run on 2 legs. Some of them run on 4 legs. Some crawl on 6 or 8 legs. Some animals move on the ground with no legs at all, like a snake. There's all kinds of ways that animals fly and swim and do all kinds of incredible things. But there are many more ways that robots or other kinds of animals on different planets or in our planet's own future could move through the world. But when we look at all of the animals and the examples we have of movement and the ways that animals should look, we tend to copy that when we make robots. And that might not be the best way to go about designing robots. It's kind of like a fish out of water. If you try to design a robot to look and behave like a human, but it's made out of metal instead of human cells, it might not work so well. So sometimes it's good to get ideas from AI to help us imagine these alien designs that could eventually result in useful technologies that help us all perform useful jobs.
And some people are questioning whether this AI algorithm can truly design a robot itself. Like ChatGPT, for example, generates information based on existing data. But can this AI create something entirely new?
So ChatGPT and a lot of modern AI systems they require massive amounts of human labeled data. So people will write many, many stories, and then ChatGPT will learn the patterns in those stories and the components and how they're arranged in different ways. And then it can create its own story in a style of an author that you like. There's other systems that take lots of human labeled images and then can create a new image based off of a new sentence. But this method that we're putting forward to design robots, it doesn't have any human feedback yet. It could in the future, but right now it starts with a completely blank slate. And the AI just starts with a random design. And of course, the random design is not going to be very good, but it can tell how to change that random design to make it better. And that's the advance that we were able to discover, is how to evaluate a robot's design and then travel back in time and say at every point in time what the robot should have looked like, how it should have moved to be better. And so the AI evaluates the robot, then goes back in time to the beginning, changes the robot's design to make it better, evaluates it, it sees that it moved a little bit farther, goes back in time and makes it better, and repeats this process just 9 times. And in, as you said, 26 seconds, it results in a highly optimized running robot.
I think that answers the question regarding the appearance of the robot. We notice it has a unique look, similar to a sponge or a soap. Is there a specific reason for designing it this way? Because it doesn't resemble the traditional concept of a robot.
Many people might not even consider this machine a robot, and that's okay. This is what I believe is the simplest thing that you could call a robot, which is why we want to get started with AI generating the simplest possible robot. Then, of course, we can make it more complex. There's other kinds of materials that typically people associate with robots, such as metals and plastics and electronics. And this self-moving machine, this robot that we created, is made just of rubber and moves with air muscles. So it's not a traditional robot, but there's reasons why you might want to make a robot out of rubber instead of titanium. And one is if that robot's going to interact with humans. It can be very dangerous if a robot is moving very fast and very powerful, and it's made of very rigid materials. So there's a whole field of soft robotics that looks at how we can make robots with materials that are more lifelike. And one thing that is very clear in animals is that they're composed of soft materials.
Oh, so that's why you use rubber robots at first, and it's not like use other materials to create us.
Yeah, we might want to use all kinds of materials in the future, and that will make the problem more complex. And we'll see how AI does when it has more than one material to play with. I believe that this process can scale to more complex robots, more materials, sensors, and all kinds of more complicated and useful materials and tasks. But who knows? That's the fun of science. It might not work. We'll see what happens.
Right. And I'm guessing the reason why it is a purple robot, is it because it's Northwestern University's color?
Of course, this is a
Yeah.
Northwestern created robot here. So we also worked with our colleagues, Andy Spielberg and Daniela Roos at MIT, and Josh Baumgart at the University of Vermont. And it was my staff scientist, David Matthews at Northwestern University, that did all the work on this project.
Oh, that's truly amazing. How do you envision using this robot in the future?
So this particular robot is probably not going to be used in the future, but its descendants will, I hope, perform useful jobs all over our planet and maybe even in outer space. You can imagine robots landing on an asteroid and mining precious metals. You can imagine robots going out into the world, picking up trash, planting trees, patching potholes. You can imagine all kinds of amazing robots that help us with repairing bridges or digging tunnels, building skyscrapers, robots that are very, very small that you can't see them, that help us detect cancer inside of our bodies. Robots could completely transform our society, science and technology, and of course our economies. And I think for the better. But we have no idea how to design any of these systems, which is why we hope that AI can help us realize these useful solutions to our problems.
So that means the robot's descendants will have many different shapes and sizes in the future.
I think that robots that perform all of these amazing tasks in all these different niches that I described, they're all going to look different. They're all going to have different sizes. Some will be enormous. Some will be very small, so small you won't be able to see them. Some will have 4 legs, 100 legs, no legs. This is why I think, just like how all of the animals in the world that survive in different corners look differently and have different sized beaks, even the different birds that have different kinds of seeds and different places that they get them in trees. This is what Darwin noticed when he went to the Galapagos Islands, is that even within finches, there's all kinds of different shapes of bird beaks, depending on how they make their living. Some need very strong, big beaks that crush, seeds to get to the inside where they can find nutrients. Some need very long, narrow beaks to reach food that's tucked away inside of plants and trees. Just like those finches, we will create robots with all kinds of different shapes so that they can perform useful jobs that require specific kinds of bodies to reach into the nooks and crannies of different kinds of environments.
And we know that the study was published on October 3rd in the Proceedings of the National Academy of Sciences. What are the next steps for your team?
We were very happy to have this paper published in such a prestigious journal. This is one of the top journals in the world, and we were very excited. We all celebrated when our paper got in. It was a tough review process. The reviewers were very good and helped the paper considerably, and we're very happy about that. The next step is, as I mentioned, we're going to move beyond just rubber. So this robot's just a ball of muscle and fat. We want to add other components. Perhaps bone will help these robots support heavier objects so they can carry objects in the world. We'd also like to add sensors so they can find their way home, and so that they don't just walk in a straight line into a wall, so they can avoid obstacles. And if you do this in very small steps, you can start working up to more intelligent robots and more useful robots. We're very far away from any robot that I think people need to be worried about, but it's good to think about this ahead of time. So as you work up, at what point do you want to stop? And I think that robots that walk, robots that see and are able to perform more useful work is very clear. We should go after these kinds of technologies. But there's all kinds of ethical questions about jobs being taken from humans, and this is going to require all of society to decide, just like every other technology, whether it's a hammer or the internet or fire. How we use it can be used for good and for bad, and it's really up to us to make sure that these new technologies are used for good.
As you said, given the rapid advancement of technology, there are concerns regarding the possibility of AI taking over human jobs or potentially losing control, leading to harmful scenarios as we often see in movies. Would that become a concern in the design process?
I think AI can help us make robots safer, because humans can only think of a few solutions to a problem. AI can think of infinite solutions, and working with humans, we can try to weed out the solutions that seem like they're going to be the safest. So it gives us more possibilities and more ideas. Robots that are made with rubber, as I mentioned, can be safer than robots made with metal. And that might not occur to a human until it works with an AI that suggests that these parts of the robot could be softer. I think that computers help people design almost everything. And this is basically the next generation of computer-aided design, AI-aided design. There's going to be humans that are helping realize these machines, and a human and a computer is always more powerful than a computer alone. And we see this in chess, for example. The best AI can beat the best human in chess and Go and all kinds of video games as well. But a human plus an AI can beat the AI in chess. And I think the same is going to be true in designing robots and designing cars and all kinds of other technologies. It's not going to be just AI, it's going to be AI plus humans. This will change the workforce. It's going to require people to learn new kinds of technologies, but it's going to create more jobs because people are going to need to repair all of these new robots, and people are going to be having to design them and work with the AI and learn how to create new AI systems. It's going to be a very different world, but there will be many jobs for humans.
Well, I think that's all we have for today. Is there anything else you would like to share with us?
That's it for now, but we're doing all those things that I mentioned. We are trying to make these robots more complex, and we are building with other materials, not just rubber, also biological materials, and trying to make biocompatible robots and biodegradable robots. Because one thing you definitely don't want to do, if you try to make a robot that's going to go into the lake or the ocean and clean up plastic, you don't want that robot being made of plastic, because many of those robots will break down and add more pollution. So creating biodegradable robots and biocompatible robots is a big mission of our lab as well.
Well, thank you so much, Professor Crickman. I really appreciate it.
Thank you.